Welcome, Math 20-3, to Topic 3.3, Volume and Capacity of Prisms. Here's a few select examples that should help you with your Build Your Skills assignment on page 171 all the way to page 178. And I'll tell you which questions you're going to have to do on that as well. All right, let's begin. So we have these word problems that start off with questions about capacity. How much water is needed to fill a pool that is 53 meters long, 28 meters wide, and 4 meters deep? What you're going to have to do is, in fact, draw. I've already spent some time drawing one of these things. It happens to be a rectangular prism. The next thing you want to do is label the values. I think that's pretty big. All right, 53 meters long, so I'm going to say that's about 53 meters long, 28 meters wide, and then 4 meters deep. Not to scale, but at least it's a rectangular prism. And make this a little bit thicker here. To calculate the volume of any prism, the volume is equivocal to length times width times height. Or, we're going to see later, it's the area of the base times the height. So, very simply, it's going to be 53 times 28 times 4. And because each of these numbers, whoops, probably not a good idea to have that look like a 3. Because each of those numbers, the 53, the 28, and the 4, okay, those are dimensions of single value, of singular linear dimensions. That also needs to include the meters times meters times meters. That's what's important about those. Okay, so in the end, our volume for this question is going to have a meters cubed value. So now I'm just going to bring my calculator up, bring it across here, and it should be cleared off. Turn it on. Yep. So 53 times 28 times 4. So the value is 5936 meters cubed. Now later on, you're going to see where you have to convert the linear dimensions or the cubic dimensions into capacity. Let me just move that off the screen here. Okay. So one thing that's assumed, although you don't really know it, is to convert values from cubic values into capacity values, such as liters. You can set up a fraction such that you have 1,000 centimeters cubed is 1 liter. Okay, the 1,000, by the way, comes from the fact that if you had a prism of 10 by 10 by 10, so if you have a prism of water that's 10 by 10 by 10 centimeters, that actually is 1 liter of water. That's how the definition of a liter actually originally came from. Okay, so you can use these ratios to solve other problems that convert your centimeters cubed into liters. Now, for this one, we have meters cubed. Okay, we're going to use the fact that we have 1 meter cubed, and I just looked online for this one, is 1,000 liters. So if I was asked this question in liter capacity and not just volume, what we do is we just simply take this 1 meter cubed per 1,000 liters and say, well, okay, we got 5,936 meters cubed. Well, how do you go from 1 to 5,936 times 5,936? So 1,000 times 5,936, which essentially is, here's a little shortcut, 5,936 timesing 1,000 gives you a few extra zeros, and the unit would be liters. So there would be the capacity of this giant pool, 5.9 million liters. All right, question number 2. Did I get it to fit in here? I'll have to zoom out a little bit. All right. For the example here, it says a rectangular prism has a dimension of 9 centimeters by 20 centimeters and 7 centimeters. Another one has 6 by 10 base, and what it would be the height, so it has the same volume as the first. Here, I've drawn out a couple pre-digital ones here. Let's just stretch that out a little nicer. Okay, so the first prism says it's 9 by 20 by 7, and it's all in centimeters. So I'm just going to label those values here. So I think 20 looks like the longer one, doesn't really matter. 20 by 9 by 7, and we'll put the centimeters, centimeters, centimeters. The volume is going to be, again, length times width times height. So it's going to be 20 times 9 times 7. Okay? So the volume, and again, these are linear dimensions, and so hence you have to have their units timesing by themselves again and again and again. So I've plugged up my calculator earlier, and it's going to be 1,260 centimeters cubed. Now I just got to grab this guy and move him over here a little bit. Now there's another cylinder that suggests, or prism rather, that has a base of 6 by 10. So if I said that's 6, that's 10, and we don't know the height, or give it an H for height. We don't know how tall it is. But we're told it has to be the exact same capacity or volume as this one. So we're going to start by figuring out this volume. Again, it's going to be, I'll do it in a different color so we can see the distinction here. Volume is equal to length times width times height, which is going to be equal to 10 times 6. The order of that doesn't matter, but here's the kicker: we don't know what the height is. 10 times 6 is going to be equal to 60 times the height. Now, the volumes of these two are supposed to be the same value. So what I can do is say that the 60 times h is the same as 1,260. The question now says 60 times something is 1,260. If I don't know what that is, well, I can simply divide out both by 60 and get the height. I've already done this question, so in my calculator, take 1,260 divided by 60, you get 21, and the units we have are centimeters. Okay, moving on to questions about volume of cylinders. Let's just give this guy some priority. All right, so volume of cylinder. I'll go back to blue. I like that. Find the volume of this cylinder. For a cylinder's volume is equal to the area of the base times the height. All volumes are defined by this. Now, check that out of that area. That shape happens to be a circle, which we know the area to calculate, if you recall, is pi r squared. And now we're times that by height. So what we have is pi times r times h. Now let's take a look at the diagram to see, do we know what these values are? The radius is the distance which is from the center to the outside of the circle, which is right here. There's your r. And then the height is given as 7 centimeters right there. Okay, so going back to the computation, how do you calculate the volume? Pi times 5 times 5 times 7. These are linear dimensions, and so we're going to have centimeter times centimeter times centimeter, giving us, in the end, to make sure we remember, we're working with centimeters cubed. So now I'm going to bring my calculator and simply type in pi times 5 times 5 times 7. You're more than welcome to use the pi button, or you can simply just use 3.14 times 5 times 5 times 7 and round in the end here. Okay, so the volume of this cylinder happens to be 549.5 centimeters cubed. Remember, if we try to convert this into using the liters, we can use that ratio, but this question doesn't ask us to do that. If we wanted to, I'll just, again, give the supplement that we said, okay, 1,000 centimeters cubed is 1 liter. We've got 549.5 centimeters cubed. And we want to know how many liters it is. Okay, we can go from this way to this way. I don't know how to go from 1,000 to 549.5. But if I take 549 by 5, or 549.5 divided by 1,000, I can find the multiplier, which conveniently is already on my screen, so divide that by 1,000. Lo and behold, that would be times 0.5495, which would tell me that times 0.5495 would tell me how many liters I have. 1 times that is going to be exactly that, so 0.5495 liters, just if I had to figure that out in liters. Or about 549 milliliters, or 550. Common soft drink ones. All right, last one. We have a secret composite figure one here. Let's just move over here. Where do we go? Got some... Oh, yeah. Look at that, baby. It's a custom $150 homemade do-it-yourself hot tub. And this is made up of a composite figure. Namely, it's made up of more than one 3D shape. Hopefully you can see we've got some sort of round end and another round end, and we have a rectangle in the middle. So if I see cut this across, and then cut it down, we could see the fact that we've got one of these. Let me just move that in here. Okay, I've made it already a group. Here's the middle part. Ta-da! And then we've got this weird stuff that on each end we've got one of these. Okay, so we've got these shapes on the end and roughly this shape. This looks like, to identify very clearly, a rectangular prism. And this looks like a half cylinder. And this also looks like a half cylinder, which we could put together, in fact. In fact, we're going to do that. Let me just grab that guy up here. Click and drag him in. All right. Let me just move that over a little bit. Okay, so essentially, to break this up, we've got a separate rectangular prism and a cylinder we could consider 2 parts of a half into a whole. Now this one's special because there's no numbers. We'd have to actually guess the value using estimation. So looking at the picture, and it's just simply a water trough, I'm gonna say that maybe that's 4 feet across. For easy sake, let's get a little thicker pen so you can see that. Okay, I'll say it's 4 feet. So there's 4. And maybe it looks like it could be a whole whopping 2 feet high. Okay, so from here to here, 2 feet, which also is the height of cylinder. Now, because it's 3rd dimension, we have no idea how far back it is. But we could make an assumption that it's the same distance deep as it is wide, if it's a nice circle. I don't know. We can say whatever we want. But I'm going to make numbers nice and easy. So I'm going to say it is across 2 feet deep this way. which also makes it 2 feet diameter of that cylinder, which means the radius must be 1 foot. Makes it nice and easy. Okay, back to blue. So we're going to figure out the volume of this shape on the rectangular prism as well as the volume of the cylinder. So the volume of the prism, length times width times height, 4 times 2 times 2, and 2 times 2 is 4, 4 times 4, 16, and these are feet, feet, feet. Okay, foot, foot, foot. So foot times foot gives us cubic feet, or feet cubed. Done. Now over here we have a, I'm just going to move it now over. Okay. Again, we have a cylinder, and we're going to use the formula the volume is equal to pi r squared times the height, or pi times r times height. So it's going to be pi. The radius we said was now going to be 1 foot. The radius is 1 foot, and the height is, we estimated, 2. And these are 1, 1, 1, 1, 1, and 2 are feet, so it's going to give us a foot cubed answer. So 1 times 1 times 2 is just simply 2. 2 times pi is roughly 6.28 cubic feet. The total volume, we just have to add this guy and this one. So the total volume is going to be 16 plus 6.28. And if I'm mentally doing this, that's 16 plus 6 is 22.28 and foot cubed. So there's your total volume. If that was completely filled up to the brim of water, okay, if that thing was completely filled up, of course, as soon as you put somebody in there, it would just spill right over. So just rough estimations giving us a total volume of a composite figure. Please follow along with the example question for that one that has a whole bunch of different boxes. On your assignment, here's what I want you to do is you're working on your build your skills. Okay? Build your skills. And you're going to start on page 171. Whoa, something just glitched out there. Page 171. I want you to do question 1 ABC. Flipping the page. Question number 2. It's kind of like my question 2 there as well. And question 3. Don't do question 4. Make sure you watch example 3 step by step on how they cut it out. Okay? You don't have to do the 5 and 6, number question 5, but I do want you to try either 6 or 7. Alright. And lastly, I would like you to do question number 8. And you have a picture, question 9. Alright, in your workbook. Thanks, and hope this helps you with doing your assignment.